that on the screen.
Okay, what's that, please? Okay, today we're going to be talking about the, what's that, guys? The geologic history of Maine. Okay? Yes, it's very exciting stuff. I promise you, this will be the most interesting lecture on the geologic history of Maine you have ever had in a marine science course. Okay?
Like rocks?
Kind of like rocks, right?
I used to collect rocks. Okay? Step off. I was an avid rock collector.
Okay, the geologic history of Maine. All right, so we've got a couple of things here. Your notes are similar to last time. It's a timeline. Just fill in the pertinent facts for each however many million years ago. What?
Are they in order this time?
My notes are, they are in order. My notes are in order this time, so I don't have to get lost. Thank you for reminding me of that. Okay, the Maine coast. Listen. The Maine coast is made up of 3 specific types of landscapes. Some of this will be a little bit of repeat as well from our first discussion on the rocky shores, okay, but not much. It's really that going into more detail because you guys were so invigorated. I mean, only like at least, Tyler's not here. He usually does the head bob more than other people, but usually, you know. What was I saying? 3 landscapes, okay? The first, or about 2,000 miles, okay, or about 58% of the coastline, is that cliffed, rocky coast that we talked about before. Okay? Cliffy, rocky coast. Cliffy. Got cliffs in it. Don't judge me. You're real me. Okay?
That ship has sailed.
1,400, or about 40%, is soft, loose, unconsolidated bluff. And I'll explain that in a second. Soft, loose, unconsolidated bluff. The rocky coast is considered consolidated bluff. That's consolidated meaning highly packed. Okay. This other area is that loose, unconsolidated, loose rocks. Okay. Large, small to medium rocks. Yes. You could call it that. Consolidated or unconsolidated sounds so much more smart. So whatever you want to call it, you go right ahead, okay? I'll call it unconsolidated bluff, so rocky shores.
From the guy that says Cliffy? My aunt had a cat named Cliffy.
Touche, all right? And then finally, only about 70 miles. Oh, sorry, this is 2,000 miles, this is 1,400 miles, right? Or 70 miles, or about 2%, is sandy beaches. Okay, so Popham, Reed State, all those beaches that you spend so much time on, Winslow Park, not White's Beach. That's different. That's not a beach. I mean, it is a beach, but it's not a real beach. Okay? Our sandy beaches. So the vast majority, again, is this rocky coast, similar to what we talked about before, consolidated. Most of the rest of it is unconsolidated bluff, meaning loose rocks. And then finally you get just a little bit that are these sandy beaches. The sandy beaches are almost exclusively in the southern part of the state, right? Down between York and Georgetown. White's Beach is a hole in the ground filled with rainwater. Okay. So these are the 3.
There's a slide.
These, you're thinking, I thought that was Coffin Pond.
No, they do have a slide.
It's a slide at White Beach.
I haven't been there in a while. I'm sorry.
It's just like a metal slide.
Listen, clearly I've brought up some traumatic childhood memories. We can work through those later. Let's focus on this, all right? So how did these 3 landscapes come to represent the coast of Maine, all right? It all started around 500 million years ago. Way back when.
What's that
500
say?
million. 500 MYA, million years ago. 500 million years ago. Okay. Back then, there was a lightweight crust to the earth covering a much heavier, denser, lower layer. Okay? Lightweight crust covering a much heavier, denser, lower layer. And when it was like a pie crust, if you will. Okay? You had this kind of soft and crumbly top, and then you had all this thick stuff down below. But what happened was, as things continued to shift, there was a lightweight materials down here, that would continue to bubble up, okay, towards the surface. Anytime there was a collection of lighter materials, it would move towards the top, okay? Sometimes this resulted in volcanoes elsewhere in the world. Good job. Sometimes this resulted in volcanoes. Other times, if the soft rising stuff did not come all the way through the crust, okay, in a volcano, it would just kind of bubble up. What's that? Okay? Yep. Listen. Listen. In here in Maine, okay? As I was saying, sometimes volcanoes would arise from this. Mount Fuji in Japan is an example, okay, of an erupting volcano. But if there was simply rises, this lighter material rose up through the denser, heavier crust, but didn't break through in the form of a volcano, it would just form little bumps, okay, in the upper crust surface, okay? So, in a second, if punch through equals volcano, if not punch through, glob, because you're going to know what this means, yep. Well, to help you out, let me show you a picture, okay, once you're done writing that. Basically, it just means, guys, if you can describe, okay, let me erase this for a second, okay. If you can picture a pie crust, right, and you've got bubbles, right, if you're making a cherry pie, okay, and you've got bubbling up stuff that comes up, okay, sometimes it bursts all the way through the top, which would be a volcano. Other times it gets to the crust and just kind of sits there and you get what's an air bubble on the crust. Yes?
Can we make pie?
No.
Can we?
But thank you for asking. Okay?
You don't have to share.
And so what this looks like then, these are pictures. This is great, guys. I told you this was going to be an exciting lecture. Unlike other times, I have pictures of the coast of Maine,
Glob.
yes, to demonstrate what I'm doing, what I'm talking about. So here you can see these globs, all right?
Those are globby.
What happened was to form these, okay? These globs are usually granite in nature, okay? And you can see that they form these bumps, okay? Where this lighter weight material broke, kind of came up through this denser stuff, didn't break through, it wasn't magma spewing out, okay, in a volcanic eruption, but it still bubbled up and created mounds, basically, okay?
So would that be like Bailey's Island?
It would be like parts of Bailey's Island, okay? Here's another example. This is an island, similar to Bailey's Island, where you've got a mounded overture, basically, okay, which is that bubbling in the crust. All right? This was 500 million years ago. Many, many. This was the original formation. And as I was saying, this turned out, this was mostly granite, which then led, of course, later on in time to the granite trade. Okay, to the granite trade. All right, these chunks of granite, which you've seen in bridges. If you're going out to Bailey's Island, you have that crisscrossed granite stone bridge. Okay, I believe it's the only one left in the United States. And that granite was quarried from that original event, or those rocks created at the original event 500 million years ago. Okay, so 500 million years ago, that's what was happening. Moving on to 380 million years ago. God. Okay, no.
It's
Black.
fun.
Matches my soul. Okay. So 380 million years ago. 380 million years ago. Okay. At this point, the world land masses look absolutely nothing like they do today. So we're all clear on that. In fact, there were completely new, different continents from what there are today. Okay. And in fact, there was an ancient continent called Avalonia. Avalonia. There was no Atlantic Ocean at this point. Okay, it's completely different. There was a different ocean, which name is escaping me at the moment. But ancient Avalonia, which is a continent, ancient Avalonia crashes into what we now call North America. Okay? Ancient Avalonia, which is a continent, crashes into North America. And the edge of Avalonia, okay, was shoved at least 6 miles over the top of North America. Okay? So it was a massive, massive impact. Okay, when these two continents collided together and drove one up over the other. Yes, sir?
Was it on the north side or the east side or the west side?
It was on the east side, which is why we're going to tie that into Maine in just a second. Okay. What happened when these collided was that there was massive pressures and intense heat, which then melted everything. Okay, so intense heat and pressure melts all rocks, not all, many rocks, but we'll say all rocks at this point, because it's just on that crust, into metamorphic rock, which still exists today, metamorphic rock. And then there are still those bits of granite that were saved. Okay, which I put on there. So with bits of granite interspersed. Okay? So they crash into each other, massive amounts of heat, hot enough to melt rocks. All these rocks get melted. And there's just little bits and pieces of granite left that were in those bubbles, okay, which are spread out around. But everything else is kind of mismatched into this giant muck of metamorphic rock.
What was the last word?
Interspersed. Now, can anyone come up with a good joke? There's a joke in here somewhere about incontinence. What is it? I can't come up with it. So you've got one continent crashing into another. It would be incontinent? Do you know what incontinence is? It's diarrhea. It's like if you're incontinent,
Stop reading.
Or was that, or is that,
We got it when you said that.
you can't pee, or is that, or, oh yeah, now I'm mixing up.
Well, if you can't.
Hey, how do you know if diarrhea is hereditary?
It runs.
Runs in your genes. Okay. Okay, so here you can see some pictures, okay? This says smashed metamorphic stuff crushed between two continents. Okay? And this is what happened. And it's not very clear. I wonder if I can focus this out.
What kind of stuff?
Rock stuff.
Like what? Inverted rocks.
Okay? You can see here, it's basically, guys listen, basically like an accordion, okay, crushed together. These are those lines in the Maine, classic Maine rocky shore. Okay, here's another example. Okay, again, you can see how basically they were crushed together. All right, two continents run together. All right, squishes all this rock, melts it, heats it, folds it up on top of itself. Okay. I think that's the only picture of that. Oh no, there's one more. Okay.
What's that say?
That's not, that's the next one. This is just still showing that crushed rock. Okay? Folded it up so. So let's skip ahead then now to 300 million years ago.
Red.
Okay? 300 million years ago. Okay? This is now when Pangea is formed. How many of you have learned about Pangea before, back in like, oh, third grade?
Pangea?
Pangea, the supercontinent. No?
Oh,
No one?
I've heard about it.
Good, okay, you've heard about it. Excellent. Okay? Fun fact. When all the land masses were massed in Pangea, Maine was somewhere in the center, down near the equator. Okay? The land mass that we now call Maine was in the center of Pangea, down towards the equator in the center of the Earth. Okay? This is when dinosaurs were around. They were walking around all over Pangea. Okay? 300 million years ago.
How do you forget dinosaurs?
And that's, guys, listen. Listen. That's an important distinction that I don't want you to forget. Whenever you say dinosaurs or whatever, and you're talking about those, and they,
Wear it?
Hello. Yes. I Joe.
Yeah, we're here.
Is Kaylin here today?
She went home sick.
She went home sick. Is what the kids are saying. Okay? No problem. All right. What I was saying before. Listen. Listen. What I was saying before is that it's important to remember when we talk about dinosaur bones being found, say, in Colorado, South Dakota, North Dakota, that doesn't necessarily mean they were found in the North Dakota and South Dakota that exists where it does today. All right? They were all connected. It was all one giant landmass, and things could travel, in theory, wherever they wanted to, from here to Africa to Europe. All that was connected. Now, they probably wouldn't travel that, but species could certainly travel those distances. Okay? But in 150, somewhere around 150 to 200 million years ago, Pangea breaks up. Okay? And it did this because magma began to form under the suture marks of Pangea. Okay, so where these islands or where these continents all came together, that's the suture point. You know what a suture is?
Like on the skull.
Yeah, it's also like stitches. Get sutured up. Okay? So just like if you had a big open wound on your arm and it gets stitched up, right? But then things start to flow underneath it, it can break those sutures. Okay? It's the same idea for Pangea. Yes?
Is there a difference between magma and magma?
Yes. There's a big difference.
Once it's formed, you get everything.
Yes. Thank you. When this magma began to pool and form under the suture marks, okay, it created rifts.
Did we talk about this? The rift?
Not yet.
I thought we did.
Did we talk about it the first time? We might have mentioned it. Okay. These rifts are still visible today. When you go down to the rocky beach, okay, this says rifts formed when Pangea broke up. Okay, and you can see these big dark lines right here? Those are those rifts. Those are from when the sutures were together, then they break apart, okay, and the land is literally split. That's what's happening here and here. Zoom in on that a little bit more, okay? Big rift. Have you ever been to the beach and seen these? Okay? That's what's happening. That was when Pangea broke up. Those rifts were formed because those were suture points that broke open when the magma flowed underneath it. Okay? All right, first, Pangea was split horizontally. Meaning the southern and northern hemispheres were split first. So first an ocean formed across the middle of the globe. Remember, there is no Atlantic Ocean at this point. There's no Pacific Ocean. Okay, the first ocean was one that split it in half.
We have some skippers.
Good for them.
What?
Then, about 100 million years ago, now that Pangea has been split like this, okay, then zippers begin to form towards the top. Up near where like Greenland, North Pole is, okay? So now the northern hemisphere basically, which is one landmass, so Europe and North America are all attached. This is now when the Atlantic Ocean basically begins. Yes, okay, Ireland and Maine were next to each other, okay? The zipper opens in north, and that's when then Europe and North America begin to separate and pull apart from each other, okay? And it was about 70 million years ago that this zipper reaches Maine. And that's when Maine gets broken off from Ireland. All the little dinosaurs in Maine wave goodbye to their dinosaur friends in Ireland. They wouldn't really wave like this, they would wave like this. Okay? And they go their separate ways. And the Atlantic Ocean forms then in between the two continents.
And then the meteors.
Yes, and then pretty quickly thereafter, very soon after this Maine breaks apart from Ireland, all right, the dinosaurs die out. Dinosaurs. Okay? It doesn't matter. That was when they now know, right, the meteor hit the Yucatan Peninsula over near Mexico, spewed pieces of Mexico up and over North America and the rest of the world, blocking up the sun. All the large terrestrial reptiles die, leaving room for smaller mammals to take over those niches. Okay? Which then led us, once the dinosaurs die out, okay, then it leads us to the Ice Age, which was basically from somewhere around, I believe, 50 or 60 million years ago, up till a couple 100,000 years ago. Okay, which were the Ice Ages, really. But we're going to all combine them into one. After this, dinosaurs are dead. Okay? Dinosaurs are dead. Okay? Global temperatures fall an average of about 5 degrees. Okay, that's it. That drop of about 5 degrees over thousands of years, okay, caused massive freezing, okay, and caused on the North Pole, and I'm assuming the South Pole, ice to then remain present year-round. And as the temperature continued to drop, that ice began to spread. Now let me just quickly, we're going to talk about climate change as our entire last unit, and it'll be your final, will be on that. But let me just point out that if temperatures dropping an average of 5 degrees can coat the entire Earth in ice, basically, not the entire Earth, but most of the northern hemisphere at least, in ice, what do you think is going to happen if they were to rise, let's say, 5 degrees? And I will point out that in the last 100 years, the average temperature on Earth has risen already 1 to 2 degrees. Okay, so think about that. And we'll come back to that later on, but just keep that in mind. 5-degree drop means northern hemisphere coated in ice that we're going to talk about. Miles and miles high of ice. What would 5 degrees up do? Okay? Ice sheets. Ice sheets are formed over most of North America. Okay, so under Ice Age, ice sheets are formed over most of North America. And there would still be seasons. We were still seasonal. So these ice sheets would melt for periods of the year and then grow back. Melt and then grow back. And they would do this seasonally to a small extent, but over time, when there were temperature fluctuations on large scales, so over 1,000 years, let's say, if the average temperature then rose another degree, then fell another degree, these ice sheets would come and go, okay? Ice sheets form, melt, and form again. Okay. They know this happened at least 4 times because the last glacier was so big and so heavy, it wiped out all the evidence from the previous glaciers and ice sheets. So they don't know exactly how many times this happened. But they know it happened at least 4, possibly as many as 10 to 15. At this point in time, the Maine coast was about 180 miles further east out into the ocean. Okay? They have evidence that the first peoples of Maine could stand off what's now known as George's Bank, which is 180 miles out into the ocean. Okay? And they could stand there and fish. And in fact, fishing trawlers to this day, all the time, when they're dredging the bottom, come up with Native American artifacts 180 miles out to sea. Okay? Because that's how far the coast went at that time. Every time these glaciers melted and receded and then came back, they would, every time they moved basically, they would scrape rocks against each other, okay, in the direction of ice movement. We'll show you a picture of that in a second. Every time, I know it's exciting. Glaciers moved, scraped rocks against each other. Okay. Even mountains were shaped by these moving glaciers. And we'll show you a picture of that too. As they moved, debris of rocks and sand were left everywhere, including along the southern portion of the state, which led to the rocky beaches, like actually the sandy beaches, like Popham, Green State, all those. I'll show you guys some of these rifts then. Okay. So here's an example of the polished rocks and slopes that happened when those glaciers moved. Here you can see, all right, you actually can't see that well because it's up here. Perhaps if I, hold on, do this. Any better? Okay. You can see these dark lines here, these ridges, okay, right here. That's where rocks were literally dragged against rocks and create these deep grooves. As well, you've got these really smooth slopes. It was basically like the glaciers sanded down the rocks as they moved. They had sand and whatever, and would rub against it, smooth these out, leave these deep incisions going through there, okay? And you can tell the glacier moved this way, okay, dragging it with it, okay? Next time you go to the beach, and you look for these cracks and these lines, you can tell whoever you're with, like, oh yeah, it's like you're tracking a glacier hundreds of millions of years later, okay? Or millions of years later. Okay, this says mountain shaped by the ice. Ice moved right to left. Okay, this is a mountain up, I think this is up near Acadia National Park. The glacier moved this way. See, this used to be here, actually used to be here, and it basically pushed the mountain over. Okay, leading to this sloping sweep here, and then a sharp, stiff cliff, sharp, steep cliff on this end, where other things were deposited as it was pushed this way. As well, around the state, you can find debris left by the glacier. Here's a big rock. Why is this rock just purchased here? Because it was left by the last glacier going through. And you can even find big piles of sand and mud, okay, around, especially by the coast, where these were also deposited. All right? Oh, that's because it's the last page. No, wait, no, it's not. That's the last page. Okay. So, final thing. We're almost done. Okay? All this glacial moving, okay, shaped the state, created the geology, right? But it also weighed down. Okay? It was so many metric tons, possibly up to 1,200 or 12, I don't remember, 12,000, 12 million, I think it's 12 million metric tons per acre, was pushing down, which literally pushed the surface of the earth into the ground. Okay? But then the glaciers melted faster than the earth could rise. Okay? So what happened was, here's the glacier melting. Here's earth, excuse me, here's earth, here's land, and then here's the water. Okay? As the glacier retreated, okay, this land started to spring up, but it didn't spring up as fast as the glacier was retreating. So what happened? All this water poured in. And that's what we talked about last time. That's what helped create the rocky shores. It also pushed the coast of Maine inland for a while until that land rose and the water went back out. Of a what? Yes, I believe so. I've heard that expression before, and I'm assuming it refers to this when the land comes back. Okay? So the ocean flooded in, and then eventually, though, this land re-rose. The ocean was pushed back out to where it is now. Okay? Interestingly, and the final point, today, he said that was the final point? That wasn't the final point. Okay. Today, the coast of Maine is bowing down again. Okay, except this time we don't have any glacier weighing us down. Basically, the coast is like a bendy stick. And up near Eastport is bowing down. Down near Wells is bowing down. Right? It's creating an arc. The point of the arc is right about where Rockport is. Have you been up to Rockport? So Rockport's basically rising, while either end of the state is bowing down. Okay? In Eastport, in the last 100 years, 3 feet per century. Portland. Portland isn't quite as dramatic. Portland's at 3. And well, with seawater, 100 years from now will be 3 inches lower. No, land will be 3 inches lower. Seawater will be 3 inches higher. This combined, this is not from global warming. This is just from geologic happenings. You combine this with global warming, who knows what's going to happen? Okay, and we'll talk about that a little bit off, but remember this. Coast of Maine, bending. Also, 2 more points, but I'm not going to write them on the board. You can just listen. Point number 1, I forgot to mention earlier, Maine is still moving away from Ireland as well. All right? Coast of Maine, North America, is moving away from Ireland every year at about the speed that your fingernails grow. Okay? So if you were to just let your fingernail grow for a year, however far that is about how far we are from Ireland, further away from Ireland we are every year. Okay? That's point 2. Oh, and finally, final point is, some of us weren't able to watch this, okay, here in class live, which is too bad. And those people that chose to go, I don't know, watch Ben, what's his name, who's a painter? Bob Ross, okay, they miss out. So I'd like to give all of you candy because you're sitting here watching it in person. If you're watching it not in person, you're not getting candy right now. I'm sorry, okay? So here you go. Take some candy. I'll just throw it out there. It's just, careful, the lights are out. Don't get hit, all right? We'll just throw handfuls of candy to everyone that's out here, okay? I'm sorry. Okay?
Whoa.
Don't duck. Okay? So I'm sorry if you're not here getting this free candy thrown out. That's up.
Why are you hating on
Okay, sorry.
international conflict?
Okay? So that's too bad. All right? One more handful each. Hold on.
Do it.
Sorry, I threw it away from you guys. All right?
Carl Brand.